talk about these bookwork problems from our dissociation reactions. So this was number 29. This was that first assignment. So we've got 3 different reactions that we are supposed to write a dissociation reaction for. So in part A, we're starting with HClO4. Okay. We know we're putting it into water. It's the aqueous, right? Aqueous always means in water. And there are 2 different ways we can write this. We can write plus H2O. And this is the way I'm going to ask you guys to write it for your quiz tomorrow. You're going to put the plus H2O there. So plus H2O yields H3O plus ClO4 negative. So let's talk about why it's that way for just a second. So we know that a hydrogen is going to be removed from this acid. This is acting as an acid in this example. Water is behaving as a base. So this hydrogen, okay, is going to leave the HClO4, join the H2O. So it's going to become H3O plus right here. So what that means is that the proton is being hydrated. Okay, so the proton that's leaving HClO4 is being hydrated and joining water to form hydroniums. Remember, this is called the hydronium ion, the H3O plus. Now that the hydrogen has left HClO4, notice this is a neutral compound. It has no charge at the beginning. But once that hydrogen has left it, it's lost a proton. One of its positive charges has went away. So now when we write what's left over, the ClO4 without the H, right, we're going to have a negative symbol because we've lost one. So every time we move one hydrogen, our charges, our signs are going to change by 1 every time because we're gaining or losing 1 proton. Okay, alternative way to write this in the way that I prefer to write dissociation reactions, and as long as I'm not asking you to identify like the acid, the conjugate acids, and base pairs and such in a reaction all the way out, this is the perfect way to write it. This is how we're going to write it next week when we're looking at ice tables. It's just simpler, faster. So all we're doing is leaving the water out. And when we leave the water out, we're showing hydrogen as a single proton. So when we leave the water off here, we're doing the same thing and leaving the water off of the H3O plus. The hydronium ion and this proton are the same thing. This one's just indicating that the proton is hydrated. It's assumed here, it's aqueous. We're assuming that it's hydrated here as well. Okay, so our HClO4 plus aqueous yields our hydrogen and our ClO4 negative. So we're just showing it dissociating, breaking apart. Okay, so a faster way to write that. Okay, so for part B, same thing. This one tried to trick you because it did not begin with an H. And that's because it's an organic compound and the way that it's written is a little tricky. So that's something we haven't gotten to yet. But for anything I'm going to give you on this quiz, if it's an acid, H is going to come at the beginning. So you'll know. It'll be pretty evident from there. Okay, so this compound, okay, plus water. Remember, water is always a pure liquid. We're going to remove an H from here, which means this one's behaving as an acid. We're going to form H3O plus, our hydronium ion. Okay, and we are going to put, that's not supposed to be ClO4 negative. That's not right. Let's fix that. Sorry about that. That should be CH3CH2CO2 negative aqueous. Ah, right answer there. Okay, so that's what we should be looking at. Did the same thing here. CH3, CH2, CO2 negative. Okay. So simpler way to write it, CH3, CH2, CO2H aqueous. Those are hydrogen ion plus this guy is a negative. Why is it negative? Well, because it lost a hydrogen, lost a proton, so now it's changed its charge by 1, so it's a negative 1. The last one, a little different. So we have NH4 plus. Okay, plus water. We're starting with that same way. Yields our hydronium ion plus NH3. Okay, let's talk about that. This one started with a +1 charge. Notice in our other examples, they were neutral at the beginning. This starts with a +1. So when we remove a proton from something with a +1 charge, all we're doing is taking the +1 away, and it's now becoming a neutral compound. And that's why NH3 doesn't have a charge here. And that's something a lot of you guys missed. Okay, so simpler way to write that, NH4 plus yields hydrogen ion plus NH3 aqueous. Okay, same thing. This shows that proton with water, shows that proton hydrated. Simpler way to write that.